Good morning and welcome, ladies and gentlemen, to our next presentation here from Phoenix Contact during the Digital Hannover Fair. Toys, silverware, flower pots, and even tools. All totally different, but they have one thing in common. Nowadays, they can all be made with a 3D printer. Additive manufacturing is the technology of the last years, and the technology has made it already several times onto the front pages of different international newspapers. The technology is developing tremendously fast, and almost daily we see new areas of application. During the next approximately 20 minutes, my colleague Johannes and I would like to take you on a journey through the history of additive manufacturing at Phoenix Contact. Thereby, we present you, of course, the spin-off of the company PROTIQ out of the Phoenix Contact Group. We want to give you a current status about the technology and show you the latest trends. Therefore, I welcome here this morning Dr. Johannes Lohn. Johannes, you are Head of Development, Marketing and Sales at PROTIQ, which is, I said already, a 100% subsidiary of Phoenix Contact. Yes, dear ladies and gentlemen, despite these strange circumstances we are all facing, we want to get in touch with you directly. Therefore, we encourage you that you write all your questions, your feedback, your comments down in the chat. We will answer this after our presentation, which will be now in approximately 19 minutes. Okay, Johannes, first question to you. In the media nowadays, we hear a lot about 3D printing. Could you explain this a bit more to our audience?
Yes, sure. First, thanks very much for this kind introduction, and also from my side, good morning. In general, you can say 3D printing, everyone knows it from everyday practice. So if you imagine a situation in your kitchen at home preparing a cake for a birthday, for example. After baking the cake, you take out the cake out of the oven, and then you take a piping bag and write down a number or a name or a simple happy birthday on a cake. And that's exactly what 3D printing is. We add material to build up a part or to write a letter or something. And that also shows where the name additive manufacturing comes from. What's the name for it in industrial application? So additive manufacturing instead of 3D printing.
Okay.
And what many people do not know, that's nothing new. Early in 1984, there was Jacques Hull that filed the first patent for additive manufacturing.
Quite a long time ago.
That's it. And in 1986, the year when I was born, he founded this company, 3D System. And this company is still existing, and they are still building AM machines. And those days it was called rapid prototyping, so it was mostly used for prototyping. But up to now, there's a huge number of technologies existing. And if you like, I can show you or give you a short overview.
Absolutely.
So on the slide, in the upper area, there are two technologies working with powder.
Okay.
And down, there are two technologies working with liquid or resin. In the upper left corner, there's a metal process. And here we use metal powder, lay down one thin layer, about 0.05 millimeters. That's half the thickness of a hair.
That's not much.
That's it. And after it, a laser exposes the surface and exposes one layer of the part. And during this process, a new layer is recoated, and then the part grows layer-wise, layer by layer. And after this
thin layer after thin layer.
That's it, on top of each other. And after the process, you have one box full of powder, and inside the powder there are the parts.
Oh, okay.
You take away the powder, you can reuse it, and just take out the parts, and the part is ready. And that's not only for metals, but also for plastics or other technologies. Like you can see, for example, in the upper right video. Here again, one layer of powder, the white area is applied, and then the laser exposes the surface. But you can see in these dark areas. And then again, a new layer of powder is applied, and it's repeated layer-wise.
So similar process as the one of the first technology.
Yeah, yeah. And down, you can see two more videos about the liquid printing process, the multi-jet modeling, for example. And that's most closely to 3D printing. It works the same way as an inkjet printer at home. You have nozzles where you apply the material, and with this process, it's also possible to produce multi-material parts.
Okay.
And the material just hardens with an UV light in the end.
So also thin layer after thin layer, but this time with a liquid.
That's it. And down right, that's the oldest technology, the SLA technology, which I mentioned before from Chuck Howell.
Yeah, that sounds absolutely fascinating. Is it possible in your eyes that now every component is more or less manufactured overnight? It sounds to me a bit like Star Trek and and the spaceship Enterprise with the replicator they used, more or less centuries ago. What is your opinion to that?
Yeah, it's a good point. There really was one model of a AM machine producer, the replicator. It was also called like this.
Okay.
And there's also some 3D printers in space already printing parts. So in general, the only thing you need is a 3D model, and then you can print the parts overnight. And that was exactly the point why we built up the PROTIQ platform in 2016. We said if you can print a part overnight, it's necessary to speed up the process before and after printing. Mm-hmm. This you can show here in this short video in the background, the marketplace.
Okay.
My colleague Stefan de Groot will explain this marketplace function more in detail next hour. The main function is that you can upload a part, get your instant price, choose technology and material, and put it to your basket as you know it from online shopping.
Sounds very similar to online shopping. When I got it right, PROTIQ is not the only company offering this printing service, is it?
That's true. As you can see here now in the video, if you choose a material and a technology, there's a wide range of service bureaus offering the same service, showing their prices. So we invite other service bureaus to join our platform with the aim to have a one-click shopping experience for the customer. He finds every technology, every material in one place within minutes.
Okay, so that, we offer a complete service to our customer then.
That's it, yeah.
Last spring, dear ladies and gentlemen, before the corona pandemic hit us, I was at a wedding, and there they had a really beautiful, wonderful wedding cake, and they also had a picture, a 3D picture of the wedding couple on top. We were all fascinated by the colors and by the resolution. I guess a wedding picture is probably not the use case we are offering at Phoenix Contact or at PROTIQ. Johannes, what are the typical applications for the industry with respect to 3D printing?
Yeah, these wedding printings are a great example for private life, but in industry you can imagine we use different technologies and have different applications.
I'm pretty sure.
One good example can be seen here in the screen. Here we have the area of tool shop, where we produce molding tools for injection molding, for example. On the picture you can see just a usual tool, quite heavy.
Quite bulky.
Bulky. Yeah,
heavy, a traditional tool as we have it in our mind, yes.
And with this new freedom of additive manufacturing, we thought, okay, it must be possible to improve this tooling. And this you can see here. So we made up a drawing, what's the basic function of the tool. And then we said, okay, we know exactly what happens during the process. So we know the forces that appear, the closing pressure, and so on, which is listed here. And with this information, we are able to automatically generate a new CD model.
Oh, okay.
So it's a different way of designing a tool in this case. This is, you can see here. So it's, it's calculated which material is needed and which material we do not need.
Okay.
And that's very important for 3D printing, because in printing we pay for each gram. So we do not pay for taking away material, but for adding material. And if you then combine it with conformal cooling, for example, you're also able to cut down cycle times.
Okay.
And in the end, a tool looks very different.
Yes.
Like you can see here, right? It's more like a bionic structure.
Yeah, when I have a look at it, also the simulation, it shows, it looks a bit like roots or bones. How is it possible then?
Yeah, so it was possible to reduce the weight massively and so on. And there's only the material left that is needed for the function. So it's like it perfectly fits the requirements.
So not just 1 gram more.
Yeah, that's it. So just perfect for the one application, much lighter, and it's possible to decrease the cycle time a lot. Yes.
The process looks very complex. Who is able to simulate this exactly?
Indeed, this was a quite complex process about 1 and 2 years ago.
Okay.
We did almost everyday business engineering services for our customers for generative design or topology optimization. But then I think it was Hannover Fair about 2 years ago. We spoke with a friend from university of mine. He had a great idea and a great solution. He had a solver for topology optimization that was able to calculate all these processes within minutes instead of hours. But he only had the solution and no front end. And so we said, okay, perfect match, PROTIQ and Thomas Reyer those days. And we made up the first online topology optimization. And now it's easy to handle and free to use for everyone. And you can calculate or generate your design online, direct at our website.
Sounds like an absolute win-win situation. With respect to tools, I know that a tool normally is always unique. Are there also standard products now available with respect to additive manufacturing?
Yeah, sure. That's an important point. But if you want to use additive manufacturing for serious production, for example, you should always use the new freedom of design. And that's why we implemented one configurator, for example, for the covers for housings of Phoenix Contact. This means that the customer can online design his own individual cover for a housing for the cabinet with own drawings on top and this company logo and so on and all functions included. So it's a 100% individual solution that can be printed on demand directly online.
But on the other hand, also a standard product, because we know a housing, most our customers out there need housings, but at the end, individualized as the customer wants it.
Yeah, that's it. Yeah.
Those examples are fascinating, and I always thought that only specific materials can be used for 3D printing. It seems there are no limitation nowadays. Are the used materials, however, as robust as the traditional ones we know, or where are the limitations with respect to materials?
Yeah. You can say there's a really wide range of materials, from metals to plastics. Also ceramics are printable, for example. You could say everything that's weldable is also processable. And the characteristics or the properties are almost the same as you mill it out of a block. In metals, for example, there's also the possibility to use heat treatment after the process. So you build up your part, then put it in the oven for hardening or something, and then you have exactly the same properties as you know from conventional manufacturing technologies.
Okay. But I guess there are materials that definitely can't be used with additive manufacturing.
Yes, sure. There's always a but. There are many materials existing, but there are some difficult materials. And one of them was said to be copper.
Okay.
Like 10 years ago, when we started with printing at Phoenix Contact with the first machine, sure, everybody thought everything must be possible. Copper should be possible too. But then there was this but. Copper is a red material, and in the process we have a red laser.
Doesn't work well together, I guess.
It's all reflected, all the energy, and that's why it was quite a long journey, which we can have a look on together.
That would be great.
As you can imagine, it is possible in our days. Here are some
we wouldn't talk about it if it wouldn't.
And here's a short timeline. So we started in 2010 with buying a machine. Then there was a saying, copper is not possible. We did not want to accept it and started with early testings and recognized with the existing machine park will never work. So we started building up an own machine. The first testing with this machine continued. And then I think it was end of 2013, first parts were generated out of the material and first application fields like induction heating appeared. So we continued with this development added optimized design for induction coils based on simulation, finished our own machine. And then in 2018, there was like the big breakthrough.
Okay.
There we tested different wavelengths for the process, and we were able to process 100% pure copper for all kind of application.
Okay. Sounds like a long process, 2010 starting and a couple of years later.
Yeah, I think if you knew this before, we wouldn't have started. But looking back is quite interesting and quite fun, because nowadays we are like the leading company producing copper in the AM sector. And that's a nice place to be then. Yeah.
I'm sure it is. With respect to our audience out there, to our product portfolio, are there already standard products from Phoenix Contact available in 3D manufacturing way?
Yeah. As we've seen before, this cover configurator. This is one example for plastics, what we manufacture in daily practice production. In this case, it was necessary to qualify the PA6 material in order to fulfill all the technical requirements.
Okay.
Then it's commonly used for prototyping a lot, or in the production phase, we are able to speed up all the product development at Phoenix Contact. And by offering this printing service for plastics and showing this cover configurator, more and more colleagues came across and asked us for a zinc application.
Okay.
Because as you can imagine, as you know, there are many components and parts offered by Phoenix Contact with zinc housings and all these little plugs. And for some application fields, we need to deliver spare parts for 20 or 30 years. And the only way to produce zinc parts up to now or up to last year was zinc die casting, so very expensive. Again, we needed to produce a tool and so on. And so we said, okay, next step, copper was done. Let's start with zinc. Yeah.
Another challenge.
Another challenge, that's it. And then it came clear that it's not that easy, because zinc melts at about 400, 500 degrees, but already evaporates at 900. So if you want to weld it with a laser, you're not building a part, but you're evaporating zinc and
taking
producing
it
fog.
away.
Yeah,
yes.
that's it. And that was one difficult point where we could again use our own machine to insert a detailed level of energy and to be able to process zinc. And here is one example for copper again, but we can in the next video see some application examples of zinc, mostly parts from Phoenix Contact, plugs with a very high level of details, also drawings, letters inside, or threads, so all printed in one platform, in one night, all parts next to each other.
Okay. Sounds, absolutely fascinating. Reminds me of the replicator in Star Trek. Yes, dear ladies and gentlemen, now it's your turn. What do you want to know about additive manufacturing, about 3D printing? Please don't hesitate to contact us, I would have said. Please write down your questions in the chat. Feel free. We are waiting for questions. I know there are a couple of participants already in the session, so it would be great if we could get feedback also from you out there. Meanwhile, a question from my side, Johannes. Where do you think is additive manufacturing in approximately 5 years?
It's a quite common question which I also ask myself every year again, because the whole technology is developing so fast. So for about 5 years ago, it was just for prototypes. Today, we are entering more and more the serious production area. But there are still some issues to solve. So the productivity, it's a fast process because we don't need any tool.
Okay.
But if you have a look on the time per part, it's still a very, very slow process, because you add layer by layer by layer.
And all thin layers only.
That's it. So there's a big need to speed up the production in order to be able to produce real series with high lot sizes in additive manufacturing.
Okay.
And I think that shows exactly where's the benefit from AM? So if the part is small, very detailed and individual, AM is the right solution.
Okay.
But if it's a standard housing, for example, if you come back to housings, it's injection molding and probably will always be injection molding and not 3D printing. So it's a combination of additive manufacturing with conventional or traditional manufacturing that brings the right solution.
Okay. Leads me to my second question. Do you think that additive manufacturing at one time will replace the traditional manufacturing, or what is your opinion on that?
It really depends on the application. So if it's very, very detailed and very individual, then it makes sense. If it's an absolute standard, it's probably not the right technology. But we will see. So there are more and more machine providers offering machines. For example, the laser melting machines traditionally had one laser. Now there are machines with 10 lasers. And they say it's 10 times the speed of the old machines. So sure, they are gathering more and more areas for serious production. And there will be a place for serious production for AM. And there will always be a place for conventional manufacturing.
Okay, so both parts have
just next to each other. We are having currently a very interesting project with the automotive sector, where we work on this combination. We have an AM machine and also a milling machine next to it, and we are adding a robot system between, so that the machine can run overnight, produce the parts, the robot takes it out and put it in the conventional milling machine, and then you have your end-use part.
Interaction also possible then, in your opinion?
Yeah.
Dear ladies and gentlemen, again, if you want to know something, please feel free to add your questions to the chat. We are waiting for your response out there. Meanwhile, another question from myself. With respect to the last couple of years, what were the greatest challenges with respect to additive manufacturing you were facing with your team?
I think the material topic is one very, very big thing. That's the technical side. But the biggest issue in my eyes is the question of design your parts.
Okay.
Because we are working with many designers that are used to work with milling or injection molding or all these technologies they know. And if you ask a CAD designer to redesign a part for additive manufacturing, he mostly does not really know the strengths of AM.
Okay.
So it's another way of thinking. If you want to use a new freedom of geometry and design, for example, conformal cooling like we had in this injection molding tool, or lightweight design, you first need to know what is possible. And I think there's a big need of training for these CAD engineers or designers.
So that it really can come to an interaction between traditional and additive manufacturing in your eyes.
Yeah, that's because it's just an additional technology that needs to be used, and you need to use the benefits or the advantages. That's why we are doing many trainings with our customers, sitting together, starting from zero, explaining how the technology works, then having a look on their part portfolio, identifying which parts are good for additive manufacturing, and then work together on the redesign as a workshop. And sometimes even these customers come in our facility, or before the pandemic situation.
Absolutely.
And we start a machine jointly. And so we have like a hands-on workshop where they can feel the technology.
So when I got you right, PROTIQ is not offering the 3D printing service itself, but also the service beforehand to talk to the customer, to get their problems, their pain points, and then together with the customer figure out the best possible solution.
Yeah, you need the complete solution to really benefit from AM for our 3D printing. It's not just printing the same part as a replicator, as we had before. The better way is to redesign and use the advantages.
And use the advantages of both, I guess.
Yeah,
Johannes, you are already quite some time with PROTIQ and with Phoenix Contact. Could you give our audience out there a few milestones during the PROTIQ history? Because a couple of years ago, you were just one part or one department at Phoenix Contact.
Yeah, sure. In 2010, we started with AM at Phoenix Contact. Those days, we were just a part of the tool shop and printed prototypes or supported our colleagues in their development phase, or also printed some improved toolings.
Okay.
And then in 2016, when our colleagues at Phoenix Contact already knew the advantages of 3D printing, and they also talked to companies, external companies. There was an technology exchange. Often there was a situation that other companies came around, said, "Oh, that's a great solution. Is it possible to buy such a kind of tool?"
Okay.
But then there was always a question how to sell a product that's not listed in our catalog to external companies. So we had a solution, but we were not really able to sell this solution. And then in 2016, the managing board of Phoenix Contact asked for new ideas of business fields. And that was our possibility. So our managing director, Mr. Gärtner, directly went there, showed the idea we need a platform for additive manufacturing, printing overnight, with online instant pricing before, with all the services surround. And then it went fast.
And then PROTIQ was born, actually.
Then PROTIQ was born, yes. So OK came in summer, and in December we were online. In the meantime, renovated a building, moved inside, built the platform, and so on. Yeah, in 2016, December, we were online. 2017, we extended the platform to become a marketplace, welcome our other service bureaus or partners on the website. And from this day on, like every half a year or every 3 months, there was something new, like a new tiny tool, a topology optimization, a configurator. So it was great. It was and is great fun.
An exciting journey, sounds like. Yes, dear ladies and gentlemen, yeah, that was it already. Thank you very much, Johannes, that you were here today to explain this very fascinating, modern, up-to-date topic to me and, of course, to you out there. Dear ladies and gentlemen, when you want to know more about additive manufacturing and, of course, additive manufacturing at Phoenix Contact, you can now speak to Johannes in person after our presentation here. Therefore, you only have to start the corresponding open live discussion or Q&A session, however you want to call it. And afterwards, in half an hour approximately, Stefan de Groot, the colleague of Johannes, will tell you more about the PROTIQ platform, so a full morning about additive manufacturing. Yeah, thank you very much for your attention. We hope we had many interesting news for you this morning, and we hope we see you soon again.
Thank you.